So March 2020. The first thing is about limits. Now, limits in this course, you don't expect to be asked questions like find the limit as x goes to 2 of 3x plus 1 over x. This you did in first year, where I just substitute. But we know the idea is that we just substitute 2 plus 1 over 2, which is 7 over 2. This will be our limit. But what will be happening in this course is that you have questions like the limit as x goes to 2 of x squared minus 4 over x minus 2. At least this you can expect, so that when you try to substitute, you get 0 over 0. So that then this rule come into play. Once you have such a thing, then you know that, oh, here, I now need to use some properties of differentiation, which is L-Hopital's rule, which also L-Hopital's rule. So that if I have it's L-Hopital's rule. L-Hopital's rule, yeah. Oh yeah, it's not English. I don't know the language. Right. Okay, so in this case, if we use this rule here, we will differentiate the direct application of differentiation. So you say, oh, this is the same thing as the limit as x goes to 2, x squared differentiated to 2x, 4 to 0, and x to 1. At this point, you can now substitute 2, and we get 4. So that becomes the limit. Well, in first year, we use the different methods. That is where it is possible. We factored out. So we factorized that one to be x minus 2 and x plus 2, and then divide by x minus 2. So you cancel here. You get the limit as x goes to 2 of x plus 2, giving us 2 plus 2, which is 4. Like that. So that now it should make sense when we go to the true shape. Question 1, A, you want the limit as x goes to 0 of 3x over tan 4x. Now, one thing we know here is that tan 0 is 0. Tan 0 is 0 because tan x is actually sin x over cos x. So when you say tan 0, we actually mean sin 0 over cos 0, which will be 0 over 1, which is 0. So this is going to be 0 over 0. So if it is 0 over 0, then we can use the rule. So we differentiate the numerator as if it's the only function that we have. So we'll get d dx of 3x, and then get d dx of tan 4x. This is going to be the limit as x goes to 0 of 3 over 4 using chain rule, and then differentiate tan. We get sec squared 4x. Then now we can substitute. When you substitute up, there's no space, so we just get 3. sec 0. Wow, sec 0 is the same thing as 1 over cos 0. This is like 1 over 1, which is 1. So when we square, we'll get 4 multiplied by 1, which is giving us 3 over 4 as the limit. Okay, the next one is B, the limit as x goes to 1, x to the power 1 over 3 minus 1 over x to the power 2 over 3 minus 1. So again, if we place 1, 1, we get 0 over 0. So we can apply the rule. So say, okay, this means that the limit as x goes to 1 of the derivative. So now we'll get the limit of the derivative. The derivative with respect to x of the numerator minus 1 over the derivative of x 2 over 3 minus 1. This is going to be the limit as x goes to 1. And then we have 1 over 3 x negative 2 over 3 over 2 over 3 x and negative 1 over 3. So the ones have disappeared. So we can now try to put the x together and see what we get. So this is going to be a limit as x goes to 1 of 1 over 3 by 3 over 2, and then x negative 2 over 3 plus 1 over 3. Which is the same thing as the limit. Or in fact, since you're dealing with 1, this is even complicating it. Since you're dealing with 1, you just substitute 1. So substitute 1 both up and down, so that 1 to n power is q1 to n power is q1. So that here now we have our final limit. This is going to be 1 over 2 as our limit. Because once we're able to substitute and we're not getting 0 over 0 or 0 power infinite or infinite over infinite or infinite power 0, then we know that we are done. That's the logic around. Okay, so we're getting to things that are a bit interesting. And like the limit as x goes to 0 of 1 minus cos of x over ln 1 plus x squared. Wow, if you place 0 again, you have 1, cos 0 is 1. So we have 1 minus 1 is 0. And then ln 1 is 0. So we have 0 over 0. So this is a 0 over 0 situation. Then we are free, you can apply the rule. So we have the limit as x goes to 0. We differentiate the negative of cos x. We'll get a positive sin x over, we get the derivative of ln 1 plus x squared. Now to differentiate ln 1 plus x squared, what we are doing here is actually differentiating Yeah, if you get the conditions, if you still get this condition after the first derivative, then you differentiate again. If you get the same conditions, you differentiate, you keep differentiating until those conditions are normal. So now we differentiate this one. To differentiate ln u, remember, differentiate ln u, what we did is you get the derivative of u itself and then divide by u. So we'll get the derivative of 1 plus x squared, we'll get 2x, and then divide by 1 plus x squared. So we'll have 2x, and then divide by 1 plus x squared. Now when you write this properly, it becomes the limit as x goes to 0, sin x 1 plus x squared over 2x. So if we place 0, 0, we get 0 over 0 again. So this is a 0 over 0 situation. So we have an issue here. So what we'll do is we'll apply the same law. So we'll differentiate now on top using product rule. The derivative of sine is cos, and then we maintain 1 plus x squared plus the derivative of Daniel.
Sir, sorry to take you a bit back. I don't get where they are down where we had sin x over 2x, then again over 1 plus x squared. How do we had, like, why is it down there like 1 plus x squared?
So when we differentiate this numerator here, we get sin x. We are done with the numerator. We now go and differentiate in the denominator. To differentiate here in the denominator, that is, we are differentiating ln u. By differentiating u and then divide by u itself. So we differentiate our u, which is 1 plus x squared, we get 2x. And then divide by the u, which is 1 plus x squared.
All right.
Okay. Then now here, we are differentiating this one using product rule. So we have sin x, the derivative of sine is cos, and then 1 plus x squared we multiply, plus the derivative of 1 plus x squared is 2x. We multiply by sin x as it is, and then divide by the derivative of 2x is 2. So we're still getting the limit. So this is the limit as x goes to 0, implying that we can now substitute because the denominator cannot be 0, so we can substitute. So when you put 0 here, this whole thing becomes 1, and cos 0 is 1, so we have 1 here. This you put 0 here, you put 0 here, we get 0 over 2. So this becomes our solution. So we have applied the rule twice. So you can apply it as many times as possible for as long as the condition is satisfied as you go on. These should be bonus questions when you go in a test. You see such a question, you rush there. Take care of it. Okay, G will get the limit as t goes to pi over 2 of sine t over t. So you substitute. We have sine pi over 2 over pi over 2. Sine pi over 2 is sine 90. We get 1 over pi over 2, which is equal to 2 over pi. So if nothing is strange, then it becomes the solution. Only for strange things, that's when we start looking for other methods. Here, the limit as t goes to 0, 1 over t minus 1 over t e 80. So here, if we substitute 0 where there is t there, you will notice that things won't make sense. So what we do is, and then again, it's not 0 over 0. So you can't use the rule. So we'll combine this. So we'll put this together. So the common denominator here is t E80. When we divide by the first t, we get E80 multiplied by 1 minus 1. At this point, if we substitute 0, 0, you understand that we get 0 over 0 because e power 0 is 1. So 1 minus 1 is 0, and then 0 there times 1 is 0 again in the denominator. So now we can apply the rule. So how do we apply it? We'll differentiate. So we'll get the limit as t goes to 0, d dt e 80 minus 1 over d dt t e 80. This is going to be the derivative of E80 is simply a. So we have the limit as t goes to 0. Derivative of E80 is a E80. Derivative of -1 is 0. And then down here, you use product rule. So we have the derivative of t, which is 1. So we get E80 multiplied by 1 plus the derivative of 80 is a. So 80 E80. Then now we can substitute the 0. So we have a on top by E0 over E0 plus a 0 E0, giving us a over 1, which is equal to a. So you must be quick to see that, oh, here there is no 0 over 0, there's no infinity over infinity, there's no 0 to the power infinite, there's no infinity to the power 0. What is there is just 1 over 0. 1 over 0 is not a situation that leads us to the rule. If I find such a thing, unlucky enough, we have fraction subtraction. So we combine them and see if that condition will be reached. And once we reach that condition, then we know we are safe. We can now apply what we know. Any question?
Yes, sir.
Yes.
Well,
Hello?
yes, sir. How did you differentiate that part? Uh, d over d d over dt open bracket e a to the power t minus 1 over d over dt open bracket t e to the power at.
So you differentiate this one alone. You differentiate it alone. When you differentiate this one alone, e to the power u, the derivative is u prime eu. So we take u to be 80. With respect to t, the derivative is a, and then you keep e80. The derivative of -1 is 0. So we are done with the numerator. Then we differentiate this one alone as well. To differentiate this one, we use product rule, because we have a product of t times e80. The derivative of t is 1. So I have 1 multiplied by e80 plus the derivative of e80 is a. Then I'll multiply by t.
Okay, sir. Thank you.
Okay. So Moses, the same way we deal with 0 over 0, this is the same way we deal with infinite over infinite. It is the same way we deal with infinite to the power 0. Though here we use a bit of different technique. The same way we deal with 0 to the power infinite. So these cases will throw you to some properties that are known. And it's the same way we deal with infinite minus infinite, or infinite plus infinite. Because you cannot add the infinities because you don't know what they are. And you can't say infinity minus infinity is 0 because they are different in their infiniteness. So what do we do to this one? In the limit as x goes to infinity, x minus the root of x squared plus x. This is like infinity minus infinity. So what do you do to it, Moses? Patrick. Daniel, I need to
So
apply like
I think we first find the derivative of that in the root. Then from there we differentiate. Then I think so.
we differentiate the one that is outside.
No, the one which is inside.
Dangerous. One is dangerous. Because if you differentiate, you don't differentiate the difference. You don't differentiate the sign. You differentiate the fraction. That gives you 0 over 0. So it becomes a bit tricky. So what you do is you say, okay, I need to make it a fraction. So we'll make it a fraction. So how do we make it a fraction? You say the limit as x goes to infinity of x minus, we can extract an x from here. And how do we plug out that x? Say, okay, since I'm in the root, if I do this, and then I'll have 1 plus 1 over x. And then, so this one is just like, then we pull out the x that is inside. We get x minus, this guy will come out as x. And then we'll remain with the root of 1 plus 1 over x. Then we factor out this. So we get the limit x goes to infinity, which is x. And then we'll have 1 minus the root of 1 plus 1 over x. Then now we write this one as, we write the x that is outside. We take it in the denominator, so we'll have 1 minus the root of 1 plus 1 over x over 1 over x. This is the same thing as it's up there. So you could take it up now and say, okay, that is the case there. But if we put now infinity inside there, 1 over x will get a 0 there if we take infinity inside. Because we're getting a 0, what we'll have is a case of 1 over. Again, there will be a 0 in the denominator. So we can actually, because I've seen that this one won't satisfy the rule. So you can separate here, use the multiplication property. So this is the limit as x goes to infinity of x multiplied by the limit as x goes to infinity of 1 minus the root of 1 plus 1 over x. So I can do this. So this one is infinite as it is, but the inside is 1 minus 1. So we get like infinite by 0 and defined. So it means that you cannot shortcut it. So I have to get back to this one. So we have like a 0 over 0 situation here. So if we check properly now, because of what has come out of this, we'll see that what we're having here is, if we take the upper one, it is the limit 1 minus as x goes to infinity, 1 minus the root of 1 plus 1 over x. If we place infinity here, we'll get 1 minus root 1, which is just 1, which is 0. So the numerator is 0. And then down, you have the limit as x goes to infinity, 1 over x. So this is 1 over infinity, which is 0. So I've obtained the property 0 over 0. So now it makes sense to say, okay, because we have obtained the property, then now I can differentiate. So let's differentiate and see what we're going to have. So if you do the first one, you get 0. Then the other one is 1 plus x negative 1 to the power half. If we differentiate this one, to give us a half down here. And then 1 plus 1 over x to the power negative half. multiplied by the derivative of the inside. The derivative of x to the power negative 1 is negative x power negative 2, which is negative 1 over x squared. So here we have the limit as x goes to infinity over negative 1 over 2x squared, the root of 1 plus 1 over x, since it's negative root. And then over, here we are getting negative 1 over x squared, which we can write as the limit as x goes to infinity of negative 1 over 2x squared, the root of 1 plus 1 over x, multiplied by x squared over negative 1, since they are fractions. So this one and this one will cancel, and then we'll have negative 1 cancelling. So what I was cancelling there was just a negative. So that we remain with the limit as x goes to infinity, 1 over 2, the root of 1 plus 1 over x. When we send the limit inside now, because the limit can go in the root. So when you send the limit inside the root, on top you have the 1, and down you have a 2 outside. This is giving us 0 here. Then we remain with the root of 1, which is just 1. So together we get 1 over 2 as our limit. Any questions? Okay, so if there are no questions, then I was just tipped that we are also on the vacation, and the test is not anytime soon. It's somewhere after when you open. So we'll be moving slowly. So tomorrow we'll look at question 2, maybe up to question 6. I think these are the same concepts. So do from 2 up to 6 without skipping any, and in depth. And then there they will do from 7 up to 30. So that there is a bit of some understanding as you go through our own as well. So we want to rejoin. We end here so that I can do the marking.
Sir, well, even I was even suggesting Sir Kanan can tuma notes, you stop posting the notes in the group, you won't post videos.
Oh, okay. I'll do so. Thank you for reminding me. I'll do like, oh, like this PDF.
Yes, sir, like the same PDF, yes.
Okay. I'll post. All right. Sheet 3, I think, okay, though we did not solve all the questions, but we solved those critical ones. But we'll get back to this.